Hi, and welcome to the introduction of DLM, a demand lifecycle management tool that facilitates your end-to-end product lifecycle management. I'm Dheeraj Rathi, and I have been working in the supply chain and manufacturing, specifically in the demand management and supply planning arena with both the processes and systems for over 19 years now. And I am the technical lead for the demand lifecycle management product. So, what is DLM? Essentially, DLM is a product that centrally manages the effects on demand planning caused by lifecycle changes in products, customers, or even locations, such as adding new ones or discontinuing existing ones. The processes supported in DLM include new product introductions, NPIs, phase-ins, phase-outs, end-of-life cycle, EOLs, and combinations of those, such as one can manage an entire PIPO effort in the application. DLM also provides the ability for users to simply create combinations with either no forecast or history, and or one can assign some fixed value forecast and or a fixed value history at the time they create a combination. The current released versions of DLM supports Oracle's the Mantra product, and the development version will bring the same capabilities to Demand Management Cloud. Having said that, let's get into the details of what is an event and what are the supported processes. An event is like a robot or like a little black box, or you might even think of it as a macro. It is a small program that does work based upon the attributes or conditions a user defines for it. This might be make item A's forecast 0 starting 4 months from now, or might be more complex, like put item A's forecast on the new item B, but only 60% of it, and also reduce A's forecast and history by 35%, and keep doing it until B is at a steady state. So an event is really a set of criteria defining how to move and treat data in the model. DLM has several predefined event types. These really act as guides for what is required as an input to accomplish a DLM goal. So let's define these a little bit tighter. A combination creator, no source. This event type simply creates combinations. One also has the option to input a fixed history and or a fixed forecast value. We can really think of this as seeding data into your model. Combination creator with source. This event type creates a combination by copying history and or forecast values from a source combination or from multiple sources. This type essentially copies old to a new, a classic chain with a combination where you can combine multiple into one group. A phase-in with no source or sourceless phase-in creates combinations with the ability to enter fixed history and or fixed forecast value with the user able to spread or build up the initial forecast over several user-defined periods in percentages, which means you will have a build-up slope. A phase-in with a source. This copies a source's history and forecast values to a new target set of combinations without affecting the source's history or forecast. In other words, we are using A to seed B, but potentially different percentages and A's real volumes. This is phase in with a classic chain. Now, a phase out is simply a time-based phasing out of combinations with predefined or custom percentages by period. So we can over time, some period of time, reduce the forecast volume to 0. Maybe we want to quit making this product available for over 3 months, or maybe over 6 months period, ramping down the forecast. Phase out supports this. An EOL, or an end of life cycle. This is essentially a single period phase out of combinations to 0 for all dates at and forward of the end of life cycle date. This basically says any population of combinations under this event will be dropped to a 0 forecast on the EOL date and for all periods past the EOL date. PIPO source cannibalization. What this allows is for us to do a phase in for a new item, say B, based upon an old item, say A, where B is going to get some of A's old volume, but also cause A to sell less in the future. This event makes new B, our target, look like A, our source, for history and forecast, but provides the ability to reduce the source's history and forecast by a set user-defined cannibalization percentage or cannibalization rates, if you would. So we introduced B and it causes A to sell less. So we forecast less for A. Also, one does not have to take A's volumes as they are. A user can set the amount A is cannibalized and can separately set the amount A contributes to B. This gives us the ability to say A will get cannibalized by B at 50%, but B will only sell at 85% of A's volumes. Now, a PIPO EOL. This acts same as a PIPO with cannibalization, but simply ends the life of A, which is our source. One can really think of this as that B's launch causes A to quit selling it all. Key functional aspects of DLM, now that we've understood what DLM does. The user interface is modern. It uses familiar tools and buttons, making it easy for users to adopt. Quickly, no plugins necessary, no additional software needed, just your browser. Centralized management. One tool to manage all of your demand lifecycle processes. EOL in one place with phase in, phase out, etc. All in all, a single tool with a single set of user interaction points. No need to be hopping across multiple tools or systems. Chaining support. Although we have discussed the various supported event types, I just want to clarify DLM supports sources and targets and many to many, many to one, one to many relationships. This means two sources could be combined to introduce a single new target, or simple A to B, or even A to B and A C. DLM also supports having sources contributing to targets such as different percentages than what the target is going to cannibalize the source, which means A's forecast can be merged and copied to B, might be 90%, while A gets cannibalized effect for 40%. Level agnostic. A DLM event can be created for any level existing in your current model, meaning these A's and B's that we've been talking about could be whole brands, product families, or even whole customer groups. This allows a single event to accomplish things like introduce an entire existing product family to a customer who has never taken this product. No need to do one by one by one. You can work at an aggregate level. Also, events continue to process during the entire length of events working life. This is not one and done. So if a new combination is introduced or a new date appears under the population for which an event is defined and managing data, that new set of data will be accounted for, processed, and managed appropriately. A good example of this is an EOL. After you EOL an item, but are still in the period where it is still selling, a new ship to buys it. Well, this creates a new combination. But because DLM looks for all processes and all existing points in the population, this new combination will also now get a zero forecast. Now, this tool allowing you to create combinations can also have a significant impact on the model itself. So one thing DLM does is it tells you the count of what you are asking an event to do. Say we launch a product category A to Germany from Great Britain. The event will tell you it is about to create 12,000 combinations. This allows the user to sanity check themselves. Does this make sense to me? If not, then just stop. Another aspect of DLM, which is importantly managing one's data, is its use of existing master data from demand management planning system. DLM's source for all item location and level data is from demand planning system. In the current version of DLM, this means your demantra tables. Therefore, we are not creating new master data or using master data that is somehow out of sync. Now we need help with assessing and understanding what is all happening around our products and life cycles and how they're being managed in DLM. We have provided some dashboarding features as well as analytical capabilities. This infrastructure is out of the box, but can be extended based upon a specific client's needs. This helps one leverage the data and efforts in the DLM as a source for decision support. Also, DLM has an event manager where all of your DLM events are visible, searchable, sortable, and available for access with advanced search features at the item, customer, or aggregate levels. This lets you quickly get to all of the different DLM events entered or that have already been doing work or have already completed their working life cycle. Again, one tool, one place to execute all DLM processes. Now let's look for some of the defining technological aspects of DLM. These are important because they show how exactly DLM can be easily brought into your data center and how well it fits in your existing IT product portfolio. DLM is designed around existing core tables. This means DLM survives upgrades and patching of the demand planning systems that are already in place. It also means DLM is nearly agnostic to the versions of those systems. This is not a tool requiring everything to be latest of the latest. DLM gets all its information from your existing model, the series or measures, levels, hierarchies, etc., all from the existing model. DLM also respects your current model by placing the DLM created values back into the demand planning system in separate series or measures that can be placed into your data or consensus flow as you see fit. DLM is quick to deploy, a short 1 to 2 week implementation cycle. This gets the tool into the hands of the users quickly and economically. Also, DLM pulls your existing security settings from the current model. Like if a user named Bob can only see division X in your demand planning tool, then he can only interact with division X in DLM. No need to separately configure security. However, local to DLM users can also be created in DLM, such that if business requirements dictate that the potential to purposely have a different security model, possibly a DLM only user, that is possible. And finally, DLM is 100% built in Oracle Apex. This means everything DLM needs is already in your data center as a part of your Oracle database. No new tech stack to license, learn, or manage.